Mark Mitcheson-Low is one of the directors at Woods Bagot office in Dubai. He is one of the lead architects on the Nakheel Tower project in Dubai, and the title of his program is Kilometer High Tower Fact or Fiction. Fact or fiction?
It's fact.
Really?
It's fact, yes.
We've heard about it for years, and those who have followed tall buildings and super talls, we used to get excited when things were proposed at 2,000 feet tall, and now we're talking about something much higher. Ground has actually been broken?
Ground has been broken, yeah. We actually started work on the foundations in February 2008, and that was continued until recently.
It sounds like the final height figure on this is not quite known, but the range of heights that you're exploring are all in the neighborhood of 1,000 meters. Is that right, give or take?
It's 1,000 meters as a habitable level. Then there's spire above, so it's a little above. It's 1,000 meters plus.
So what's going on at the site? What's the status out there, and when is something else besides hole drilling going to start happening?
Well, the first work on the site was putting in the barrettes and the diaphragm wall. The diaphragm walls was completed in November 2008. We continued to put in the foundations until about February 2009, where they've been put on hold until for a short time while Nakheel revised their program for the project. It was going to be a 10-year program. It'll probably be stretched out a little bit further than that. But we're actually majority complete for the foundations under the superstructure. So there's over 50-60% of the foundations are in already.
The barrettes that you mentioned, 168 of them have been completed. There are how many total?
There's about 300 of the large barrettes that sits directly under the superstructure. Then there's some further smaller barrettes that sit under the secondary structure. So of the major large barrettes, yes, 50% are done. That's 168. So most of the work under the major superstructure has been complete.
And these are square concrete columns that go down to founding elevation, is that right?
They are, yes. We did very deep bore tests. We had 2 sites to look at originally, and we went down to about 350 metres with the geotech, and because we wanted to check whether there was a greater bearing at a bit larger depth. What we found is the best we could get was about 80 to 90 metres of crust, and under that it went a bit plastic. It went sort of jelly-like. So we devised with the engineers, WSP, Candescenic, devised the foundation system using these large barrettes of 2.8 by 1.5 metres, and they go down to about 85 metres and anchor the building into that crust.
And the crust, a lot of places in the world don't have the luxury of bedrock that they can get to, so it's really kind of whatever the layer and its characteristics will bear.
Yeah.
Is that right? There's no such thing as bedrock there. What's under this? What's this crust like, and what's under it?
It's not bedrock. You know, in fact, the whole area is an old salt plain, obviously being desert, and the Gulf was further inland, so it's a sediment crust that's made up of sort of shale and sort of light limestone, if you like.
But the foundation that's being built, how long is this phase of construction? You've got the barrettes, and then you have a raft on top of that of some sort. Is that right?
Yeah, that's right. That's right. And the raft will be the next thing to pour when the project recommences, and the foundations are complete. So really, the estimate was that we were going to be at least 3 years in the ground, completing the foundations and ready to go before we started coming out of the ground.
So in the next how many years?
And we've been 18 months to 2 years in the ground, building the diaphragm wall and the foundation. So we're over 50% through the foundations.
Okay. So I'm sorry, the foundation will be finished when, and you'll be ready to start superstructure about what time on the timeline?
Well, the Nakheel currently the project's on hold, and they're revising the project in 2010 with a new program. So I guess when it restarts, we're back on a 10-year program for the whole project. We've already spent 18 months to 2 years, so we're looking at another 8 to 10 years to complete.
This design, I imagine, is the product of many iterations and a progression of designs that were required to get to this point. Those of us who watch the tall building world remember a proposal called Al Burge, which I think was called the Pinnacle. Is this project the extension or conclusion of that, or is it a totally different project?
It's a totally different project. That I think the one that you're talking about was actually on the Palm originally, and it was about 600 metres high. It was purely one use, it was purely residential, and it didn't have a mixed use component. This project is completely mixed use, and obviously is a lot larger than that project, and it's a completely different project in its design. The mixed use, which has office, residential, branded residential, 5-star hotel, 7-star hotel, an observation deck, obviously takes a greater population. It's a 24-hour tower, 7 days a week because of the mix, and the demands on the cores, obviously with 156 lifts, virtually creates a vertical transit system. So the tower is much larger in its diameter, with an aspect ratio of 1,000 metres to 100 metre diameter, 1 to 10 aspect ratio. Means that it's a much larger footprint than many other towers. And there's a reason that we've designed this in a cylindrical shape with the slots through it, because it allows the wind to pass through, and we're not tapering the building in as it gets higher. So constructability is the name of the game to be able to get the tower completed quicker, and the repetition of building higher means that obviously a speed of construction saves money.
Let's go more into the origins of this project. As I said, we in the tall building world have been watching for a number of years where projects of this scale have been rumored, but for how many years has this actually been a reality that you've been working on?
Okay. The team was assembled in October 2006, and that team is an international team, including WSP, Candescenic, Les Robinson is part of that structural team, Norman Disney Young, MEP engineers, and Rick Barker from Barker Mahandas are the lifting engineers. So obviously that major core team was assembled very early. Then we've had a raft of specialists. In fact, we've had over 350 specialists, consultants working on the project, plus another 300 or 400 model makers and people on site, and various other minor specialists working on the project. So a team of 700 built up from the October 2006 till early 2009.
It sounds like where a lot of skyscraper projects start out with a design and a concept drawing, this one started out with constructability and engineering. Is that right, as its core?
Yeah, as architects, we like to work really closely with engineers, and on a very tall tower, particularly of this height, engineering and lifting consultants, obviously, the number of elevators, etc. And with the mixed use, put a high demand on that, because the services, obviously for the mixed use, as we changed where we might put those uses and changed the height, the population of the tower increased or decreased, and the number of lifts changed. So we worked very closely with the structural engineers right from the beginning to develop a tower that could be virtually extruded for as far as we could before there was any tapering or changing. There were two reasons for that. One, we've kept the 100-metre diameter and made the centre of the building hollow, and then put slots in it so that we can get light and air into that. But then we use the slots so that the wind passes through. I mean, wind is the greatest enemy when you get higher up the building. So allowing the wind to pass through them means we don't have to step the building in. So we're not changing the form as we go up. So every time you change a building technique, every time you step the building in, you're changing all your forms. You're changing the team has to reconfigure how they're working. And quite often the facade elements change as well. The way that we've developed this with the engineers is it's a very regular shape, and the gravity forces are taken all the way down to the foundation, so there's no stepping, which means we can virtually extrude the development right up to level 200. and with no change. And the same facade components are on level 10, or on level 100 and level 200. So it means that we've got three only major facade components to do 75% of the building.
Am I right in thinking that whereas a lot of architects will try to sketch out the body of the building in just a general shape, that your first task or your priority was coming up with a kind of form that could be extruded, and worrying more about a cross-section than the height of the building and the way it would look?
We because the team was based in Dubai, and we're surrounded by the regional elements that we get used to seeing every day, and Islamic pattern making is common everywhere. You sort of live with it, and so we wanted to make sure that the project was bedded in the place that it was being built. And when you look at the geometry, Arabic geometry and pattern making, it always radiates out from a centerpiece, and then there's a geometry that starts to join intersecting points, which quite often end up in stars, or it ends up in a radiating circle. And you see this in the construction of buildings such as mosques and domes, and you see it in the patterns in tiles. So we actually use that, and we ran that past the engineers, that if we use this very geometric shape that had intersecting points, we could use that virtually like a radiating grid. And we ended up with a 16-point star, if you like, around the outside. So we worked with the engineers, and they turned into 16 mega columns around the outside. And then to create the slots, we joined some of those stars and pulled them into a center point, which gave us the slots for the wind to come through, and that created hammer walls. And then to join it in the center, as I said, radiating circles are very common in the Arabic pattern making. So we used the centerpiece as a drum wall, if you like, that took a lot of the vertical gravity loads. So in working with that, we ended up with a plan that we felt worked well, and the engineers also worked well, because it's the unity that's in that pattern making also gives unity in the structure. And it actually came very quickly, that part of it. But then we tested it against, what if we did a rectangular building? What if we did a triangular building? But the wind loads always work better around a circular building. We didn't have to worry about orientation and things like that. So the actual plan came from that original discussion, and the fact that we had 100 meters diameter and the atrium core that we worked with. So what happened from there is that we ended up, once we dissected it, the circular plan with the slots, we ended up with 4 towers, in fact. So we took those 4, so then we stacked those 4 towers, so we ended up with 4 towers that are 25 stories high. So we've broken a very large, what could be a large element, into smaller elements. So we then bundled each of those 25-story segments together and tied them together with the sky bridges, a 3-level sky bridge, which was like a belt truss that tied it together. So if you can imagine a stick of bamboo, it's hollow, and then it's joined at knots all the way up. And those 4 towers, a 4-tower approach, really was a big change, a big shift from a traditional skyscraper. A traditional skyscraper usually has, most of the ones we've seen, have a center core, and they step as they go up to reduce the wind sail. But the efficiency of those upper levels becomes a very small footprint that you can't really use for a lot. The pity about that is that you've spent the most expensive part of building the tower is when it gets higher, and you're not getting the return on it because it's the smallest footprint. So by doing this extruded type tower, we've got the same footprint on the lower level as we have on the upper level, which means we're still carrying a large square meter net lettable area right at the top of the building. And that obviously for a return to a developer has got to be better than a tapered building.
Well, speaking of returns to developer, of course, the returns start coming in when there is occupancy.
Yeah.
And with such a long construction program and the fact that you are kind of stacking 25-story buildings, is it possible or is it likely that the lower sections will be occupied while the upper sections are being built?
Yeah, we had planned a staged occupancy because of the 25-story 4 25-story tower, and then the bridge links. And because of the way that we were changing the uses we were going up, we could actually occupy some of those lower levels after we got, a reasonable way up. After we got to the second sky bridge or whatever, we could start having early occupancy of some of the spaces. However, it was part of a bigger site. There was a master plan for a bigger site and a very large podium. I mean, the tower itself was over 900,000 square metres, just the tower, and had a population of about 15,000 people at its peak. The podium that was then servicing that tower was another 800,000 square metres, because it was taking what was going to be what is going to be in the future, a new city centre, and the metro rail that connects to that, the station has just been. So it becomes a major city centre point, and that podium also included galleries, exhibition centres, retail, and obviously all the servicing for the tower in a lower podium with the car parking and plant rooms and off-site loading docks for waste removal and deliveries, etc. So it was virtually like an airport terminal underneath the building, servicing this tower. And so the stage completion needed to be also staged at the ground level, so you could get access and have part of that podium completed.
Some of the other characteristics of this building, you're going for LEED Gold standard, which I wouldn't say it's surprising for a building like this, but it's certainly a challenge. And just some of the things that I picked out of your notes here are titanium panels that are 100% recyclable, and it's a process similar to the aerospace industry. And that got me thinking that over the life of a building, something like this is going to be pretty permanent. And the titanium recycling, is that recycling building components, recycling the facade? What is that exactly?
It's basically that we're using components that can be recycled at the end of the life of the building, so it's not environmentally damaging. But one of the brief items was that the client wanted the building to last for at least 100 years, and obviously we know the buildings last a lot longer than that. And so the finishes of the building had to be of high quality as well. Dubai also is very tough on buildings. The environment is you get large dust storms, but you've also on a coastal strip that gets a lot of humidity and a lot of environmental air changes that obviously affect the buildings greatly. So we wanted to make sure the building could be easily cleaned, etc. So it's a very sort of robust external facade, and with the latest in technology in glass and cladding systems that obviously energy efficient. But the sustainability wasn't one big item. You can't do one big item in a tower like this. There are about 200 items that the MEP consultants had, of maximising recyclable material and waste and water and a whole lot of heat exchange areas throughout the tower. We've got a tower that could have 25 degrees Celsius difference in temperature from the bottom to the top, and 25 degrees difference from the outside to the inside if you've got 50 degrees outside. So they were using all that as much as they could to make the building very efficient. And what we tried to do was make sure that we could get LEED Gold through a raft of items, and not necessarily go for the things that may be more gimmicky, that don't add a lot to that. So we felt that people were saying we should look at wind turbines because we've got the slots, and we said, well, we need to make the building work without those things, and then if we decide to introduce them, they're just an extra percentage onto the sustainability.
The design life of the building, 100 years, but you would think that it would last longer than that.
If it takes 10 years to build, you would hope it would last longer than 100 years.
You would hope so anyway, and this brings to mind our technical tour of the John Hancock Center the other day, and that building's been there 40 years and has undergone several redesigns on various floors to kind of bring it up to date, but some of the big dumb systems are finally nearing the end of their design life, and it's time to replace them after the building's 40 years old now. And as I look at a building like this, maybe I've been reading too many science fiction stories, but I think of this lasting a lot longer than than 100 years.
No one's going to pull it down, obviously.
Well, no, and not
100 years
anytime
is a long
soon.
time in the UAE life of a building, but obviously this building's built to last for a long time. And one of the things you may have seen in an early presentation is that when we got the team together, which came from, they came from everywhere, New York, San Francisco, London, and we sat down to look at the project, we really felt that we had to try and future-proof it as much as we could. We're building something that's not going to be completed for a decade, and we're using systems and technology that's going to be potentially old by the time we get the building complete. So the whole idea was to make the building, the tube if you like, adaptable and flexible as much as we could. Now the 4 legs that we have in each of the 25 levels are serviced from each of the sky bridges. But there are 4 sets of plant there, and the beauty about that is that there's a certain amount of redundancy. So that if one of the legs goes down or one of the legs loses plant or equipment, they're all connected so that the other 3 can back it up. Now that means that in the future we can take out bits of plant and replace it and still have the building running, and then you can gradually replace. So in say 30, 40 years time, we've got the flexibility to start re-energizing the building with new technology. And I think that's the beauty about the simple form of the building and the sky bridges that link that, is that we have that flexibility. One of the other things that we thought about was obviously the lift technology is going to change, elevator technology, and the way that we have designed the lifts at the moment, which is 156 lifts, is that you can use lifts or stairs in a fire situation, escape situation. So the fire and safety and health side of the building is that because we have these four legs, we've got banks of lifts that are double-decker high-speed express lifts that can go up to 560 metres, and they can then you can then depart out of there and use the local lifts. Now our thinking and our planning in the building is that if lifts can then suddenly go to the next sky bridge, we've stacked them so that we can actually go to the next level once lifting technology changes. So we can actually take those express lifts a bit higher. What that does for fire and safety and having the express lifts and being able to use the lifts in the case of fire means that the sky bridges become refuge zones. So if in one leg there's an incident, you've got a choice of going up or down in the local lifts, and then in a refuge zone changing to 3 other alternative lift banks to either go up or down to another refuge zone or go out of the building. So there's multiple ways of leaving the building. With a population of 15,000, we don't plan on evacuating the whole building at once. The refuge zones are where people would go to until they're directed to go to another bank of lifts and exit the building. So these 4 legs not only give redundancy in the plant and equipment, but also give you a very safe building for fire and safety.
One of the terms that you mentioned I'd not heard before, future-proof, which I really like, because as any homeowner knows, I've got a 90-year-old house. Pretty soon the plumbing's got to be replaced eventually, and things do wear out. And as far as the building systems that I mentioned earlier, it's hard to envision some of these building systems being totally gutted and replaced in a certain amount of time. Is there a 100-year design life on some of the, for lack of a better term, dumber building systems, just the pipes and the conduits that are just needed to get things done?
We were trying to hold off when we talked about future-proofing. We were trying to hold off on things that we knew were being developed now that we didn't have to make a decision on right now. So we're putting the capacity, but if we felt that there was something that we know is in evolution and maybe 5 years' time, it will be at a point where we can use it. We were trying to make the building as flexible as possible, so we didn't have to make that decision too early. So as long as a major plant and we know that the loads are there, that we were able to make that decision a little bit further down the track.
So you must be constantly evaluating. This is still very much an unfinished work, where the design of the building will continue to evolve just because you have the time, if nothing else. I
think it's a critical path thing. Yeah, you know what you have to do. We know the superstructure has to go in. We know that we have to size ducts, etc. The beauty about the hollow core, by the way, is that when we were playing with the building like a thermometer, and maybe we'd move residential or hotel to a different leg, which means the lifts would change. But because we had this hollow core, we could actually had a little bit of flexibility in squeezing it up and putting more lifts in or putting more shafts in if we required. Whereas when you've got a central core, all you've got, when you start moving out, you're taking up lettable space. We were taking up air. You know, we weren't really affecting the lettable space. So it gave us a bit more flexibility in the building to be able to adjust to make sure we had enough servicing in there and servicing shafts.
You know the Dubai market because you've been in Dubai for how many years now?
9 years now.
Are people there accepting, you're really talking about a major lifestyle change for some, moving into a vertical city, which in theory anyway, if you have your work and your home there, you never have to leave, which of course is nothing new. We have that right here in Chicago. But that is a major lifestyle change from an area that has been largely not very much there. Are people accepting of it? Who's going to be living here?
Well, I think the difference with Dubai is that, yes, a lot of the local Emiratis would possibly still live in villas and prefer that lifestyle. But there's a change because there's a huge young population, not only from Emiratis but from the region. It's sitting in the middle of a region that has got a huge catchment, and because Dubai is very progressive and offers lifestyle to the region, and also offers freehold, which a lot of people can't get in purchasing their own apartment. I think that it already is a high-rise city. It already has a lot of towers in the city, and people, I myself live in an apartment there, and people are used to living that way. The other issue that people need to understand is that of the UAE, Dubai is not a large emirate, and so, which is one of the reasons why we saw the Palm and projects like that develop out into the Gulf, because most people tend to want to be along the coastline rather than going into the desert, and by doing that, the coastline of Dubai was expanded enormously by the Three Palms. But similarly, there's a strip that you think of how much has been built in the last 10 years, and it's really building a city in the last 10 years. I mean, the density is increased enormously, and the amount of product that's been built has been massive. But then you look at what's been done in 10 years, and you say, well, in the next 50 years, even when considering we're going through a slump now, but assuming it comes back even in the next 10 years to a very dominant market as it has been, because it is in this centre, because you can buy in there, it means that the land's going to run out pretty quickly. And so, land banking is building taller and building tall towers is a land bank for the future, because they're going to run out eventually. And I don't think it's certainly a place that's not going to stop being popular in the region. So it is going to keep on growing in the future.
Mark Mitcheson-Low is the director of the Woods Bagot, or is a director at Woods Bagot in Dubai. Kilometer high tower fact or fiction, it's happening now. This is the Council on Tall Buildings and Urban Habitat 2009 conference in Chicago.